Today I wanted to give everyone an opportunity to see some applications involving systems of equations. One real-life application involves the use of the law of supply and demand. If you're not familiar with the law of supply and demand, here it is. The law of supply and demand is a theory that explains the interaction between the sellers of a resource and the buyers for that resource. The theory defines how the relationship between the availability of a particular product and the desire or demand for that product has on its price. The law of demand says that at higher prices, buyers will demand less of an economic good. The law of supply says that at higher prices, sellers will supply more of an economic good. These two laws interact to determine the actual market prices and volume of goods that are traded on the market. This point is referred to as the equilibrium price. As you can see to the right, I have a system of equations that's been graphed for you. The green part of the graph represents the demand. The demand says that the lower the price, the more of a demand. So that's why it's decreasing in a negative direction. And then with the purple part of the graph, that represents the supply. The law of supply states that the higher the price, the more of a supply is needed. That's why from left to right, you can see that that part of the graph is increasing in a positive direction. So let's try an example. Looking at example 1, it says the following system represents the supply and demand functions for basic haircuts at Salon Ultra Blue, where Y is the quantity of haircuts demanded or supplied when the price of haircuts is X dollars. Solve the system algebraically to find the price at which the supply of haircuts equals the demand. So we're given a system here where y equals negative 5x plus 350 and y equals 1/10 x squared minus x minus 5. So we're going to need to solve this algebraically and find the point of intersection, which in this case is going to be our equilibrium price, in which the supply of haircuts equals the demand. To get started with these two equations, I can see that they're both y equals. This would be a great opportunity to use substitution. So I'm going to replace negative 5x plus 350 in for y into equation number 2. So I get negative 5x plus 350 equals 1/10 x squared minus x minus 5. And since this is a quadratic, I'm going to move all of my terms over to one side. So 5x, I'm going to add to both sides, and I'm going to subtract 350. So my left-hand side is gone. It's 0 equals 1/10 x squared plus 4x minus 355. And now I need to solve this quadratic equation. I could try factoring it, I could try completing the square, but probably the best method of choice is to use quadratic formula. And so to make this a little bit easier on ourselves, I could get rid of this fraction by multiplying both sides by a factor of 10. So I'm going to multiply both sides by 10, and I get 0 equals x squared plus 40x minus 3,550. And that way, when I do quadratic formula, I don't have any fractions to deal with. So A is 1, B is 40, C is negative 3,550. Let's plug that into quadratic formula. X equals opposite of B, so negative 40 plus or minus. Square root of 40 squared minus 4AC all over 2 times A. And let's simplify this. I get negative 40 plus or minus the square root of 15,800 all over 2 times 1, which is 2. And then I'll type this in my calculator. So I'll have negative 40 plus the square root of 15,800 over 2. And x equals negative 40 minus the square root of 15,800 all over 2. And I get two answers, negative 82.6 as well as 42.9. Now remember, X is representing the price of haircuts in dollars. We can't have a negative amount of cost for a haircut, so the only answer that's reasonable is this 42.9. So we know that the cost of a haircut is going to be $42.9. And now I need to find the y coordinate, which is going to represent the number of haircuts that are needed at that price to maximize our profit. So to do that, I'm going to take the 42.9 and I'm going to plug it into one of my two original equations. I'll pick the first one. Y equals -5 times 42.9 plus 350. And I get y equals approximately 136. Right? We can't have a decimal for a number of haircuts, so we're going to round up or round down based off that decimal place. And we're going to, in this case, round to 136. So this tells us that I need 136 haircuts at $42.90 per haircut in order to maximize our profit. After you got your answer, I would highly encourage you to check this solution by graphing. You could visit Desmos.com and then graph these two equations to confirm your solutions.